The Sieve of Eratosthenes. That's what we're going to look at next. And I'm sure this is probably something you've never seen before. The Greek mathematician that's credited with this is Eratosthenes. So first of all, let's talk about what a sieve is. A sieve is it's like a mesh, like a strainer, right? Like when you drain pasta. Or how they used to pan for gold is they would scoop up dirt into this sieve and they would run water through it and they would shake it and all the small particles would fall through and what would be left is the little nuggets of gold, right? Or maybe you do this at the beach and you scoop up some sand and then you run the sieve through some water and all the sand goes through and you have the shells that are left on the top. So this sieve, this process we're going to do is going to act like a sieve, and what it's going to do is filter out all the composite numbers where the only little gold nuggets or shells that are going to be left in our sieve are going to be the prime numbers. So this is a way for us to get all of the prime numbers from 1 through 150. That's as far as I went. If you go online, you can, actually if you go to Wikipedia, they have a pretty good explanation of this and they'll show you all the prime numbers. Then there's online ones and ways you can find out if you need prime numbers bigger than 150. But prime numbers have kind of baffled mathematicians for years because there's no pattern to them. And you'll see when we're done here, there is no pattern. So here's how we figure out all of the prime numbers. This is one way to do it. First thing is you want to go to the number 1 that's in the list. Well, 1 is not prime, so I'm going to mark it off. Okay. You're going to go to the first number in your list here that's prime and you want to circle it. Okay. So 2 is the first prime number. What you're going to do then is go and mark off all of the multiples of 2. Because if it's a multiple of 2, it's composite because it would be divisible by 2. So it's not prime. So then you go through your list and you mark off all of the ones that end in even numbers essentially. So that's going to end up being like this entire column that ends in 2, this entire column. This is time consuming. This entire column, this one, and this one. But I want to go back and make a note of something. So we circle 2, and then we cross off all multiples of 2. That's what we did. So we circled 2. I want you to notice if we had gone in order, the very first multiple we would have crossed off would have been 4. Okay? So I just want to make a note in here. The first one is 4. We're going to see a pattern that's going to kind of emerge with the first number that you cross off. Okay, so we got rid of all the multiples of 2. Now we're going to go to the next number, 3. 3 is prime. So we're going to circle 3, and then we're going to cross off all multiples of 3. So circle 3. So as we go down the list to start crossing off the multiples of 3, the first one we would come to is 6, but it's already been crossed off. So if we keep going, 9 is the first one that we get to that's a multiple of 3 that's not crossed off. First one is 9. So we'd cross off 9 and then 12. You skip count. 13, 14, 15, 16, 17, 18 is already crossed off. Basically, you're going to start to get some diagonals going in here. That one's already crossed off. 27. And you're going to notice that the numbers you're crossing off add up to a multiple of 3. So like 30, 33, see if you add the digits, 36, 37, 38, 39, and then we start to get some diagonals, like there's a diagonal there, there's one, 45, 54, 63, 72, 81, or you can skip count, it's like however you want to do this, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and you go through and you cross off all of these. Oh wait, that might not have been the right one. Anyway, you cross off all the multiples of 3. I'm going to spare you all the details. Then we go to the next one, it's 5. As we go to cross off all the multiples of 5, the first one we come to is 25. Okay, and that's important that we know that first one we come to is 25. If you want to cross off all of the multiples of 5, right, it's all the stuff that ends in a 5 or ends in a 0. Okay, and then we would go to 7. 7 is our next prime number. And as we go to mark off all the multiples of 7, what you'll notice is as you go through here, they've all been marked off. The first one we get to that's not marked off is 49. And then you would skip count and you would go through all of your 7s and you would cross them all off. Then you go to 11. You'll notice when you get to 11, that's the next prime number. The first number you cross off that hasn't been crossed off yet will be 121 down here. And then we keep going. And then you'll have 13. And then you cross off all the multiples of 13. And then 17. And then 19. Okay. And through the magic of technology, and I think I marked off one that was not the correct one, but that's okay. This is not very fancy technology. Once you go through this whole process, oh, I knew it. There was one right there I shouldn't have crossed off. All the ones that are left are the prime numbers. All these uncircled ones are the prime numbers that are left. All of the other numbers will eventually end up getting all crossed off. And usually, you can do this like with a virtual sieve that you can find online, or you can watch it, somebody do it. But the point is you end up with this nice list of all of the prime numbers from 1 through 150. And if you look at it, you can see there's no patterns to it. So all of the circled numbers would be the prime numbers. This 113 that I accidentally crossed off, that one is actually prime. So again, those are what all of your prime numbers would look like if you do this process. And the fact that we were crossing off, the first one we crossed off for 2 was 4. The first one we crossed off for 3 was 9. The first one we crossed off for 5 was 25. That squaring pattern is going to come up next on something called the square root test, which is something that you can use to determine if a number is prime.